Hello team, welcome back. In the previous section, we have learned that how we can create an end-to-end application using the ANN, which is Artificial Neural Network. In this section, we will learn about the RNN and we will see that how we can create an end-to-end application using the RNN. So we will learn about the deep learnings, we will learn about the sequential data, and we will learn about the RNN. So let's start with the introduction. What is the deep learning? So we have already learned about the deep learning because this is the term which we have explained multiple times in the previous lecture. But still, this is the one line definition which I can put on the deep learning. Deep learning ultimately a subset of the machine learning. Machine learning is a broad area, and in the machine learning, there's a deep learning which uses the neural network and the multi-layer concept to model the data patterns. We have already seen in the previous lectures in the ANN that how we was using the neural network and how we was using the multiple hidden layers to format a data or to model a particular data patterns. We have also created a couple of data patterns in the earlier section. What are the key components of the deep learning? Definitely we learn about it. The first is neurons, which are the basic building blocks of the neural network. Second is the activation function. Earlier as well in the ANN model, we have used a couple of activation functions. We have used the sigmoid and we also used the ReLU. And we have discussed about the ReLU and the sigmoid in quite details. Second is the layers. We have seen the hidden layers. We have also seen that how we can optimize the hidden layers. We have seen that how we can use, we have also seen that how we can select the sizing of the hidden layers or select the sizing of the neurons in a particular hidden layers. So layers are basically something which will organize the structure of the neurons from input hidden to the output layers. And then in last, we have seen the training. Training involved the feeding of data, computing the loss, computing the accuracy, and updating the weights using the techniques like backpropagation. These are the key concepts of the deep learning. Now, these key concepts are going to same either you are working with the RNN, you are working with the ANN. The deep learning concept is going to be the same. But there is some difference between the ANN and the RNN, and the difference is sequential data. RNN basically work on the sequential data. Now, what is the sequential data? Sequential data is something which will refer a data where order of the data matters. Let's suppose you are putting a tables, correct? Then that is sequential data. You are using the Prometheus to monitor your applications. Correct? Prometheus is a tool which is used to monitor the applications or events in the DevOps. So that is a sequential data because Prometheus is putting the data in the time series format. What is the data at X time? What is the data at Y time? What is the data at Z time? On the similar fashion, you are using the stock markets. That is a sequential data because price of the stock is basically recorded in a sequence manner against the timestamp. So there will be the n number of examples which will have the sequential data. And whenever you want to put the machine learning, you want to put the artificial intelligence on the sequential data, you can use the RNN model. Correct. So time series data, like the Prometheus is generating the time series data. Whenever you are putting the log, the application log, the software logs, it doesn't matter what is the logging you are using, right? That is a time series data because you are writing the log in a time series manner. You are writing the application log every second. Speech, that is the sequential data. Text, that is the sequential data. So any data which inherit the sequential pattern, that is the sequential data and that must be modeled accurately. If you are breaking the sequence, then definitely you will not get the accuracy. What could be the common use case of the sequential data? Time series forecasting. Predicting the future values based on the past or previous values. That is the common use case, like the stock prices, temperature trends. You see, that is a very common application in your mobile phone, the weather forecast. How you are doing the weather forecast? Time series data. You are reading the previous data to forecast the weather in the upcoming 15 days, 14 days. Correct? The stock prices. Analysts are predicting that stock will go high, stock will go down, or stock will stay there. You can do the same thing using the artificial intelligence application. and there are n number of applications available in the market, the applications doing the same work. They are not doing anything new. You can also create such kind of application. Even you can take it as a task that I will create such application which will predict the stock. And what do you need? You just need the previous data of that stock which you can easily get from the stock market or the stock exchange. Correct? Time series data forecasting. That is the first or very common use case of the sequential data. Speech recognition, converting the spoken language into the text. That is the common use case of the sequential data. NLP, natural language processing. Applications where you need the sentiment analysis, you need the text generation, or you need the translation. Sequential data will be used in that particular kind of applications. Now, let's try to understand the architecture of the RNN, recurrent neural network. What is the basic and high level architecture of the RNN? We will discuss about the RNN and the other stuff in quite details in the upcoming lecture, but this is just a introduction lecture so we are going through the basic concepts. Correct. What is the RNN? What is the recurrent neural network? Recurrent neural network are specialized for the sequential data. Whenever you want to put the AI on the sequential data, you can think about the RNN. Right. The RNN leverages the sequence order by maintaining a memory of past input through the recurrent connections. So whenever you are processing the data in the RNN, you can also referring the sequence order of that particular input. Let's suppose you are processing the XYZ input. Whenever you are processing that input, you need to trace all back data, the complete sequence of that particular input. That is the RNN. So in the RNN, we will have the input. The input will be a sequence of data points. You need to define the data, which is a sequential data. Then there will be the hidden state. Again, this is the hidden layers, which will maintain a memory of the previous input and update it each time at each step. It means if you have the two hidden layers, then in each step, then every hidden layer is creating its memory. Correct? And next hidden layer is consuming the input along with that memory. Whatever the previous data you have attached with that particular input, the next hidden layer will basically process the complete data along with the history. And next will be the output. Produce the prediction of each time stamp. In the ANN, you was not maintaining the memory, but the memory of the previous input will be maintained in the RNN. And that's why RNN is comparatively high resource consuming compared to the ANN models. The computation power, machine power, you will need a good machine whenever you are processing the RNN application. You will need the GPUs. Recurrent neural network architecture can be presented with a few terms. The first thing is we can call it XT. XT means the input at a particular step at time t. What is the input value at a particular time stamp t? Because this refer the timestamp data or time series data, so it will also measure the data against a particular time value. HT is something which will define the hidden state at a time stamp t. So XT is defining the input at a particular time. HT is defining the hidden state of that input at a particular time. And next one is the HT minus 1, which is defining the hidden state from the previous timestamp. Hidden state from the previous timestamp. It is not just processing the input at a current hidden layer, it is also referring the input from the previous timestamp, and this works in a recursive model. This is the formula which you can use to calculate the RNN. So in the RNN, whenever you are calculating or the system is calculating the hidden state at a particular time t, this is the formula which can be used. So formula is very simple. Here W define the weight of the current input. U define the weight of the previous hidden state. If there is a previous hidden state, then you will define the weight of the previous hidden state. B define the bias term. F define the activation function. XT define the input at a timestamp t, and HT minus 1 define the hidden state from the previous timestamp. This is the basic formula by which a hidden state can be calculated at a particular time t in the RNN architecture. So let's do one thing. Let's create a basic program and let's try to understand the RNN on the basis of that particular program. Very basic program. We will create a very basic program. So earlier we was working with the ANN application project. This is the section number 15 and I will create a new folder over here called 15 hyphen RNN project. In the RNN app project, we will create a file called 1 hyphen basic RNN example dot ipynb. Correct. Over here, what we will do, so this is going to be basic RNN application. We'll start writing up the code. Let me minimize this. Very first, we will put some import statements. And what we will import? We will import the couple of libraries. So very first, we will import we'll select the kernel. And very first, what we will do, we will start the import statement. We will import a couple of libraries. What is the library we need to import? Let's import the NumPy. Very first, we will import the NumPy for the data modeling as nm. Then we will import the library from the TensorFlow. So from tensorflow.keras.models import from TensorFlow Keras models import, we will import a couple of library. Very first, we will import the sequential. What is this sequential? Sequential is a linear stack of the layers from the Keras API. So we can create the n number of hidden layers, right? Input layer, hidden layer, and the output layer. Sequential is a linear stack of the layers. This is the simplest way to basically create the layers in your data. This is the simplest way basically to create the layers in your neural network. Then we will import a couple of more libraries from a TensorFlow, tensorflow.keras.layers. Import, we'll import the simple RNN. This is the first library we will import. And second, we will import the dense. Now, what is the purpose of the simple RNN and what is the purpose of the dense? So let me put some comment about the simple RNN first. Simple RNN. What is the simple RNN? Simple RNN is basically a RNN library, right? And this library has a mechanism, that helps to capture the pattern. It has a memory mechanism that helps to capture the pattern over a time. This is about the simple RNN. Next, dense. We have already seen the dense in the previous lectures, in the ANN lectures. What is the purpose of the dense? Dense provide the connection between the layers. This is a fully connected layer to get the output from the hidden layers. Correct? This is the purpose of the dense. Now the import is done. Very next, what we need to do? Next, we need to define the input data. What we will define? We will define the input data. And we are working on the RNN. It means we need some sequential data. So let's suppose we are taking a sample temperature data of the 7 days. Correct? We are taking a temperature of the 7 days and next we will predict that what is going to be the temperature on the next day. So here I will get the input data and let's suppose this is the input data for 7 days. This is the temperature 1, 2, 3, 4, 5, 6, 7. After the input data, what is the next? Next we need the data preparation. Data preparation means format this data into the RNN format. How RNN will basically use this particular data. We need to prepare the data models for the RNN. So we will reshape this data to the RNN input. And how we will do the reshape? The basis of the NumPy. So let's suppose we are using the nm, or let's take it instead of the nm, let's take it mp, NumPy. So we are taking np dot array, and what we will do? We will traverse the data from the last index, temperature data, and we will get it from the last dot, and we will use a function called reshape. We'll use this function. What is the reshape? If you will keep your mouse over here, you see what is the purpose of the reshape. The purpose of reshape is basically to convert your data into the 3D format. We will convert our data into the 3D format. And what are those 3D format? And that 3D format is going to be this: sample, time step, and the feature. So what is the sample? We will take one at a time. We will define the one, comma. Next is time step. What could be the time step? Time step could be the number of past days. If we are taking 1 as a sample, then we can take rest 6 as a time stamp. So we will define the 6. Then we will define the feature. So let's suppose we are taking one feature per timestamp. This is how we are reshaping our data. And let's store this data in a variable called input data. We are reshaping our data and storing this into a variable called input data. We will define the output. Again, we will use the np.array, use this data and take -1. -1 means last index. This one. Why we are taking it as an output? We are taking it as an output so that we are saying that this is the input and this is the output. Compute this data and we will get this output. Correct? On the basis of this input and output, we will train our model. So we have created the data preparation. Next, what we need to do? Next, we need to define the RNN model. So again, we need to create the object of the sequential. So we will create the object of the sequential. We have already created it in the previous lectures as well. Again, one more thing. If you want to print the input and output, let's print it. Print input data and print output data. Let's see if we are able to process this data or not. Execute your program and you see. This is the input you are getting, the 3D array, and this is the output you are getting. Correct? It means it is working fine. There's no issue. I will close this, close this. Now define the RNN model. Very first, we will create the object of the sequential. So this is the way how we are creating the object of the sequential. Next, we need to train our model. So what we have did, we have initialized the blank sequential. Next, we will add the layers in this particular sequential. Whatever the sequential we have initialized, we will add the layer in this particular sequential. How we can add the layers? Simply use this object dot add, and now we will use the simple RNN library which we have implemented, which we imported. Correct? We will use the simple RNN. What is the purpose of the simple RNN? A recurrent neural network layer that processes the sequential data, and that's the same thing what we are doing. We have created the empty object of the sequential. Now we are adding the layers. Very first layer we are adding the simple RNN. This simple RNN basically will accept a couple of inputs. Right? Let me tell you what are the inputs it will accept. Very first, it will accept the number of neurons, which it calls the units. Let's suppose we are defining 10. So this particular model will have the 10 neurons, 10 units. Each unit will process the input data and remember the output of the previous timestamp. So this is the number of neurons we are defining, the units. Next, we need to define the input underscore shape. What is this input shape? Let's suppose we are defining 6, correct? The timestamp and the 6, comma 1. What is this 6 and what is this 1? 6 is the time steps and 1 is the feature. What does it mean? It means there will be the 10 units, the 10 neurons. Each will process the 6 step, correct, against the 1 feature value. Then we will define the model dot add, and we will define the dense, and we will define 1 over here. It means we are just taking the one layer, a fully connected layer which will produce the output directly. We are not taking the multiple layers, no hidden layers, no multiple hidden layers, just one layer, a single linear layer which will process the input and produce the output, the direct output. So once you have done up to this particular point, next what you need to do, you need to compile your model. So we need to compile the model. How we can compile this model? Model is being created. We have added the required details over here. Now we need to compile this model. How we can compile it? We need to use some kind of features to compile the model. So let's suppose we are using model.compile. We need to use the optimizer. In the earlier as well, we have used the Adam as a optimizer. So we are using a optimizer called Adam. And second, we need to use the loss function. So let's suppose we are using a loss function called mean squared underscore error. Right. So these are the two things which we need to use whenever we are compiling a model. We need to use the optimizer. We are using the Adam, which we have used in the ANN as well, and we are using a loss function. Here, the Adam optimizer is basically used to assign the weights to the input in each processing with the minimum loss. And the loss function mean squared error. This will be used to basically measure the difference between the predicted and the actual temperature, right? The mean squared error, this is the common loss function basically which is used in the linear regression. So we have compiled the model. Next, what we need to do after the compilation, what we need to do? Next, we need to train the model, right? So we need to use the fit transformation. So we are using the fit transformation. Fit transformation will accept the input data, it will accept the output data, it will accept the epochs, right? The timestamp and use the verbose. So what is the mean of epoch 100? So this is the input, this is the output, this is the iteration. So basically this, so whenever we are defining the epoch 100, it means this particular model will iterate this input data 100 times, right? Because we have defined the value 100. This particular transformation, the fit model will iterate this particular input data 100 times to learn the relationship between the input and the output. Verbose 0 means suppress the output during the training. Now, we have done all the things. We have basically defined the data, we have prepared the data, we defined the RNN model, we compiled the data, we trained our model. Next what? Next is simple. The prediction. Define for the prediction. We are predicting the temperature in the centigrade. Simple, we are using the model.predict, defining the input set, and this will predict the temperature. So let's execute our program. You see it is executing. And we are getting the predicted temperature in minus. You see it is saying minus 1.43. As per my program, what it should do, it should predict the temperature of the 7th day, right? We are producing it as an input data, we are providing the input of the 6 days. Now it should predict the temperature of the 7th day, but it is not predicting rightly. So what is the meaning of it? The meaning is very simple. Your program is not basically compiling the data. Your program is basically not compiling the data as it should. So what we can do, the option we have, we can increase the number of units. Let's suppose we are defining 100. Instead of the 10, we are defining 100. Let's execute. This time it took 2 seconds, but basically we are getting some good data. Earlier temperature was 30, 32, 31, 33, 35. Now it is saying that, okay, it could be 18. Let's increase the epoch as well. Instead of the 100, let's choose 500. Right? We are training our model in more efficient manner. It will train a lot of data, then it will give me some value. You see, now it is very close. It is saying that the temperature will be 34.80. Let's suppose we are changing the temperature completely. We are taking 0, -1, -5, 1, -3, -1, -6. Let's see how it will behave. Executing it again. It is taking the time. You see, the temperature of the 7th day will straight -6. As per my data, my model is working fine. If we will increase this a bit more, let's suppose we are taking 1000. We are changing the temperature again. 10, 8, 2, 8, 6, 21, and 12. So you see, I have done a lot of variation. For any machine learning program to predict the next value could be different. It could be difficult, but let's see how it will behave. We are executing it. It is working. It is preparing the data. It is doing the computation. And let's see what is the output we will get. It is saying that the predicted temperature will be the 12th. The 7th day predicted temperature will be the 12th, and it is predicting accurate data. So team, this is the basic example of the RNN. We have defined some sequential data. Let's suppose we are defining actual sequential data 10, 11, 12, 13, 14, 15, 16. And we are asking our program to predict the next value. Either it will predict the 16 or either it will predict the 17. Let's wait. You see, it is predicting the 16. So team, this is the way how we can basically use the RNN and how we can execute the RNN model on the sequential data. This is just a very basic simple program. In the upcoming lectures, we will discuss about the RNN in quite details and we will create a couple of end-to-end projects as well with the large data set, with the huge data set. So that's all for the day. If you have any question, any doubt, you can let me know. Thank you team. See you next time.